So let me show you a fun little demo involving gates. Now, I want you to be very careful here. Lots of caveats here. So if your grandmother asks you, how big is a gate, don't say this big. So this is how big gates used to be, I would say, when they were first invented. Okay, when they built gates out of discrete vacuum tubes and so on, this is how big a gate used to be. So this is roughly that big. Today, in a chip, in a small VLSI, very large scale integrated circuit in a chip, which is about 1 centimeter on the side, how many gates do you think I can fit in a thumbnail sized chip? Any guesses? With today's technology, how many gates can I fit on a chip? It has to be more than 1 million, because I just told you the Pentium 4 was 20 million. And that was a year ago. How many? 40 million is a good guess. So on the order of 40 to 80 million gates in a 1 square centimeter. Intel just announced that they'll be shipping a 1 billion, a chip containing 1 billion switches. Okay, remember, this whole thing is a gate, right? Inverter, a resistor, and a switch. This thing is a switch. So Intel's going to be shipping something containing 1 billion of those little elements. Okay, just keep those large numbers in mind. So here's a little circuit that I showed you here. A, B, the NAND gate at the output, and the inverter. Okay? So this output is going to be 1 whenever either A or B is off. Okay, so the output is a 1 in this case when both A and B are off. I turn A to 1, output is still a 1. So the moment I turn both of these inputs to a 1, these are 1s, the output goes to 0. That's behavior of a NAND gate. Okay, if I switch any one of the inputs to a 0, the output should go to a 1. Okay? Similarly, for the inverter here, when the output is a 0, input's a 0, the output's a 1. And when I switch it, so should the output. Okay, now imagine a circuit, a little chip, containing billions of these devices. Okay? And just imagine all of these 1s and 0s flying around. So one simple switch in the input, like a click of a keystroke, could actually cause 1 billion signals in your circuit to be flipping around. Okay, and that causes some fun stuff to happen, which we will learn about a few months from now. But for now, that's a quick show of a little circuit that looks like that. Okay?